Hello everyone, I'm your host. Your wait is almost over, but before starting this Astra Block workshop, please watch the intro clip. See you in a second.
I found someone new now. I have more room, no more formats to chain me. On the same page, we are effortless, schemaless, living in the future, you and me, made for us, serverless, living in the future of the clouds.
Good morning, good evening, good afternoon, everyone. Happy to have you during this workshop. Today we will discuss about blockchain and web3, and I will show you a new product called Astra Block. I'm your host, Cédric Lunven, and I'm leading the developer advocacy team at DataStax. I'm a trainer, speaker, developer support. I'm building some sample apps in Java. I also have my own open source framework called FF4J. And we are doing everything we can for everyone to succeed with Cassandra. Later, I will be joined by Alex Leventer, who actually build the code, build the Astra Block solution. So stay tuned. A little bit of housekeeping to start, as usual. So you might have noticed, but the format is a bit different. I'm still with you in the comment answering your question live, but the session is actually recorded. The material has been built by the team. Here you see distributed across the world, and probably some of them will be as well with me in the chat answering your question. It's a workshop, not a webinar, so expect you to do some work. You will work. All the code source is available for you on GitHub. You don't have to install anything. We will provide you the database and the IDE. Let's get started. What is blockchain and what could be the Web3 opportunities? So blockchain is a distributed system, decentralized. It's called a ledger. So a ledger is the type of storage database, if you want, where everything is happen only, and it's like a logging file. It's like a log, big log file. So it's distributed and also decentralized. So each node is in charge of the file and will get the copy of the blockchain. Sounds familiar, right? Some of the pattern you might find from Apache Cassandra. So in a blockchain, multiple component, data that you will store are transaction, group into block. Block are hashed. So each block got an address and a hashing code. And this is how you will validate that a block has not been altered, because you will validate the hashing. And then when the block is generated, available, could have been mine actually, it will be inserted in the blockchain. The previous block will get a reference to the next block. And because it's a chain, you cannot break the chain. You cannot remove one of the block, replaced by another one. Everybody will notice because the previous block will get the reference, and you will see that it's rebroken. So blockchain could be used actually to ensure that the data has not been altered. When you read and write from a blockchain, you need a consensus. So a couple of nodes will have the data, and you need to get the majority of the node to answer your request for the transaction to be validated. Again, sounds familiar if you already used Cassandra before. So how does this work? So blockchain is distributed across multiple machines. You will write into the blockchain. Step one, a transaction is sent. the block representing the transaction is created. The block is sent to every node in the network, like distributed commit. Each node validates the transaction, here that's step 4, and get reward for that, reward of the proof of work. So there is some reward for you to do blockchain, to actually be part of the blockchain. And finally, as I told you before, the block is inserted in the chain and the transaction is marked as complete. So immediately you should realize that writing something there could be slow, right? Because it's distributed and all the member of the blockchain needs to answer, or at least half of the node needs to answer. So if your blockchain is big with a lot of nodes, it could take a while for the transaction to happen. What should you do? What are the use cases with the blockchain? Well, as I told you, once the data is in the blockchain, it cannot be altered, corrupted. So first, it could be used for non-fungible token or NFT. So it's a way to prove that you own the asset, because you in the transaction you have the asset name and your identity as well as a code. So people could create some art or asset or even stuff in the real world as an NFT, and to mark the ownership of that NFT, that could be part of the blockchain. What is true for different assets in the world of art is also true for gaming and social. If I jump on number 3, if you are looting some equipment during a game, role-playing game, and you earn a unique object, if the unique object is saved as well as part of the blockchain, it's the proof that you own that unique item. And with that unaltered data, you will be able to sell your equipment to somebody else. That's the guarantee that it's unique and not had been altered. And always the same idea, what I just explained to you, unique, not had been altered, secure, could be also applied in health, insurance, and also finance. It's in the middle here, distributed finance here. So loan, deposit, remittance, asset swap, everything could be part of the blockchain and secure. Think about Bitcoin, Ethereum, of course, where there you will find coins. And with that guarantee of the blockchains, you can actually exchange some cryptocurrency with the guarantee that there is no invalid transaction there. But it's a distributed system, and the CAP theorem still applied, so it's hard to ensure both consistency, availability, and partition tolerance. In the case of the blockchain, they call about scalability, decentralization, and security. If you want to ensure scalability and decentralization, well, the more node you add, more node needs to be part of the transaction. So security or performance could be it, right? So it's hard to scale efficiently with the blockchain. And until now, I even told you about write and the performance that are it when you write, but it's the same when you read. When you read a transaction as well, you want to get the majority of the node to get you some data, and it could be slow. So what if you want to retrieve a lot amount of transaction and block to do some analytics? Well, it will take a while for performance. Maybe it will also provide some data inconsistency in between the node. So other challenges for the blockchain, cost. It's a lot of machine. So it costs in the hardware. It also costs in energy. Imagine for each transaction you are doing, there is a lot of node involved that will consume a lot of energy. And this is why you may have heard that blockchain is already consuming as much as a small country in terms of electricity, and you need a couple of nuclear power plants just to make the blockchain, Bitcoin blockchain running. But not all blockchains needs to be that huge. You can have, small, private, purpose-oriented blockchain providing the features, but not be so much consuming in power. So you are reading the slide with me. So also issue with security, privacy, compliancy. What if your data needs to be in one country for GDPR or any regulation law? Cannot really run on blockchain with not distributed across the world. Data consistency, always the CAP problem. And everything in blockchain is pretty raw. Address, hashing function, token. Yeah, not so easy to read and use. You need some serious skill to make that work. And last but not least, complex infrastructure, but I already explained that. All right, so now if you want to build an app using this blockchain world, cryptocurrency, NFT, or any blockchain actually, you want to build an app, and if you look on the right part of, and if you look on the left part of the screen, you have the regular blockchain with read and writes, both slow. What could be interesting if you can subscribe to the blockchain in a way and extract the data in another database easy to read. So everyone will still write the transaction and block in the chain using the blockchain protocol message change. Transaction will be validated the same, but to read, and especially to read a wide amount of data, now you can go to the copy of the blockchain, that database, to do read. So this copy is kind of read-only, right? Because it's just there for you to easily navigate across the data. And the database could be formatted in a way to simplify your request. That's the purpose of the database, right? You could save all your data on file system and it would work, but then it will be hard to query. This is also why you see different flavors of databases, NoSQL, relational, document-oriented, colon. You save the data in a way, in a format that is easy to select. Here is the same. So to build Web3 apps, why not interacting with some DB in read-only to get the content of the blockchain? And without further ado, I can show you what we will do today. It's the Ethereum Explorer here. So this is the app we want you to build, or at least run. We provide you the code. So here you see the different transaction, the amount of Ether. So it's a Ethereum blockchain. Here you have access to the transaction, and you get the items of the transaction. So as you can see, you get approved by, trade on, token approvals. You get the name of the block, and you can actually see ownership, and that is that. And the contract, making it super secure. Exciting, right? And you will have that running at the end of the session. What kind of data could be exported? Well, Astra Block will do a full copy of the Ethereum blockchain with multiple entities: block, contracts, log, token. Here you see transaction, NFT. And to get a detail of every single entity and table, you get here the link on the screen. I will also show you by request what it looks like. All right, you now have an understanding about what a blockchain is and what you want to do with Web3 apps. We also introduced that offloading a blockchain in a dedicated database could be valuable. Which database will you pick for that? Well, stop asking, because we have the solution for you, and surprise, it's Apache Cassandra and the Astra platform. So Apache Cassandra, in a nutshell, it's a NoSQL distributed database. You can install on a single machine, but the idea is really to install on multiple machines. Each node will get 2 to 4 terabytes of data, and you can execute a lot of transactions per second on each node, multiple thousand transactions per second and per core. Those nodes are grouped into a data center or ring, and there is no master. They communicate to each other using something gossiping. So very look like a blockchain, but here actually the blocks are not saved in chains. They are saved as tables, and the data is distributed as well across the node. So if I save a table, not a block, you expect to find a primary key to answer the unicity of the record, or there you also find something called a partition key. And the idea is based on the value of the partition key, data will be distributed across the node. You save together what you want to retrieve together. And because the data is distributed that way, and if you add nodes to the ring, the data is reshuffled, nodes are balanced, and you can scale as much as you want. And with multiple transactions per second, it's way faster than what you expect from blockchain. And also, if you provide the proper argument in the where clause, so here it's a column in red, you will access a single node. So not only the data is distributed, but also the workload is distributed. That's what allows you to scale. How much can you scale? Here a slide presented by Apple last year at ApacheCon, stating that they have over 300,000 nodes. Crazy, right? With petabytes of data and millions of queries per second. Some systems are like that, of course, but here we are telling you that system is real time, OLTP. We are not doing end of the day queries here. It's real time. So they have multiple of petabytes online and still have, millis response time. Pretty crazy. You can install Cassandra on one DC, one ring, but in the Cassandra cluster, you can also have multiple rings. And this is Cassandra job to replicate the data to multiple nodes. Again, you can read and write from any node. There is no master, and data is replicated for you. So there is no master. The same data is also available on multiple nodes, replication. And actually, this is for you to decide how many times the data is replicated. You will provide something called the replication factor. So if you add those two components, you realize that A, you can lose any of the nodes. Actually, you can even lose a whole region, and your app is still available because it will fall back to the remaining data centers. So this is why we're stating that with Cassandra, you can build apps that do not, fail. There is no RTO, RPO. If something goes down, there is always another node ready to take over. And in a nutshell, why would you do Cassandra? Availability, scalability, low latency, and global distribution. And that actually fit what you would like to achieve by reading against the blockchain. So this is what we will do, no surprise. But instead of you running Cassandra locally, it's a distributed system, not so easy to have those multiple machines in sync. At DataStax, we provide Cassandra as a service. And the platform is called DataStax Astra. In the platform, you see multiple services, a database running with Cassandra, a streaming solution, a broker running with Apache Pulsar. And of course, we have smooth integration between the two of them. When you write into Cassandra DB, an event can be sent in Pulsar and vice versa. If you want an event in Pulsar, it can end up saved in Cassandra. In this cloud solution, a lot of interfaces available for you to interact with. From HTTP API, if you are familiar with front-end, and some multiple messaging format if you want to interact with messaging. Today, the app we will run is a TypeScript JavaScript app, and it makes sense to interact with the data using some HTTP API. Probably easier than the native drivers. And so today we will pick the GraphQL API for our answer. So this is what Astra DB look like. But you know what? I think now it's already time for our first lab. Okay, so here first I open the GitHub repository. So same on our organization DataStax Dev as all our workshop. And the workshop here, it's called Workshop Astra Block. Okay, all the instructions are in the README and all the code is available for you, including the slides actually. So here on the right part of the screen, you see Astra DB. And what I will do is go over the end zone and say step number 1, create an Astra account. So here it is. For the workshop today, you need a GitHub account or Google account because we will authenticate against all the system we use today with one of those 2 accounts. I was already logged in. Let me pick one of what I already have. So here I'm on my organization. So when you start, you have your own organization. So here is the email address. And in Astra, you can create or be part of multiple organizations and add people to your organization. So what you want to do here to interact with your database is to create a token. So very important because this will serve as your credential. So to get those, we are going into settings here. We are picking token management. I will select a role, organization administrator. So it's easier because this role got everything. It's always easier for you to use. And then I will generate a token and here I can download the details. For security reason, this token will not be shown to you after that. Okay, so there you are saving here for later use. Okay, and with that, I already did 1.1, 1.2. I created the Astra token. So far, so good. So let's jump back into the slide. I would like to give you an overview of what Astra Block is. I already explained very high level, but we can do better. So in Astra Block, you will get a copy of the blockchain in an easier way to read. So it will also decode the chain data. Okay, so all the data model part of the blockchain is there included, and it's built on Apache Cassandra. Okay, table and deploy in Astra DB. So maybe this is the most important slide for you to understand Astra Block. So the blockchain is running Ethereum with all this distributed node. First, we have a blockchain indexer. This is the component that will subscribe to the blockchain, and each event sent will be recorded. This is how we are doing a copy. It's not a copy in one go. It's the copy has been done in a while, and now the indexer will add every single transaction to the copy. It's indexed, and it will end up in our master DataStax Astra Block database. Okay, and when the data are saved into this master database, events are sent. Remember using Pulsar. This is what CDC means, change data capture. Each time you save in the master database, an event is triggered and sent to the replicate. What are the replicate? Well, your replicate. So when you will create a Astra Block database, the database will be initialized. Then it will switch in maintenance suspended mode for all the data to be poured in your instance. Then it will become active again. And from that moment, every new event coming from the blockchain will be sent to the DataStax master database and sent to your database using CDC. But for you, it's transparent. You don't even have to think about it. So now your local copy of the blockchain is also updated in real time. And what can be done for one blockchain can also be done for multiple blockchain. As of today, we do have the Ethereum blockchain available, but nothing blocking us for have multiple. Once the data is in Astra DB, so you open a new range of use case. So first use case, easy transaction per transaction read with real-time microservice apps and API. And this is what the Ethereum blockchain Explorer is doing, right? If you provide an address, a block address, you will get the details of the block. Okay, so you know what Astra Block is, and the user interface. When we will create an Astra Block, you will have multiple choices. You can either import the complete data set, or you can only import the schema. That's for you to decide. And for instance, if you only import the schema and then enable the change data capture, you will not get the initial load, but we will still get the new transaction pulled to the database. So it could be useful to test mode, and also not only making you pay, because Astra is free for the first 80 million transaction a month. And after that, you start to pay from a transaction. So if you do a full copy of the blockchain, you will exit the free range. And to be able for you to test Astra Block for free, we allow this version where we copy the empty database and you get only the new transaction. And when you feel ready, import the whole dataset. Okay, so with that, I think we are ready for lab number 2. So Astra Block quick start. So not everyone would be enabled on Astra Block. It's features that you need to request for that to become available. So here there is a registration page. So this is where I'm going, right? So datastax.com/product/Astra Block. And here you will request access. So here you will provide the field as I already did, and you will request some access. So it's asynchronous. Internal team will validate your request, and soon enough, when you will, so probably a couple of days, when you will connect to the Astra UI, you will see now this blockchain component available. So because today it's only 2 hours workshop, you will not get your account validated for the blockchain. But do not worry. For today, we will provide you some credentials to work with our own copy for now. And after the session, you can request access and work with your own copy. Okay, it's just for the matter of live that we will give you a temporary token. And here it is. So once you get your token, let me pick another organization, for instance. Once you get your token, you can here have access to a clone blockchain database. So here I will click on clock blockchain. I'm select the blockchain. So here, as you can see, I can only have the empty table, or I could have the complete data set. If I say complete data set, I will call it blockchain, whatever, blockchain demo. Which cloud do you want? So that's Astra DB running on multiple cloud. The free region, if you are using a free account, will be Google Cloud, US East 1. And by clicking, you agree that you to the DataStax private policy and term of service. So let's do it. I now clone the database. So here you can see that I got the database cloning message, And here my database is pending, then initializing, and then the data will start flowing. Okay. After a while, here I will get this database already running. It's called Ethereum, right? And because it's a blockchain database, you get the regular Astra DB tabs, but you also have the block tab. So the block tab is the CDC. So that's really that make your database updating. So if I disable here block, now your database will not get the new block copy. And if I enable the block, you enable again the copy, and anything new will be poured into your database. Okay. All right. So here, SQL console. So this part is more for now a demo because you really cannot create a database right now. But soon enough, I will give you a way to interact with an existing database, but not with SQL SH. So the first thing we want to use is use Ethereum. Let me see if I can make it bigger. Here it is. Okay. Maybe I can even open that in full screen. Okay. All right. So first things we want to do is use Ethereum. All right. And maybe I can describe the tables. It's not there, but describe tables. Okay, so a lot of components from the blockchain. If I want to show you exactly the token, so I will describe table token. So in a token, you get the address, block number, block hash, timestamp. Okay. And what would be cool is just for you to say a few blocks. So here I will simply list you a few blocks. So here you got the address of the block, decimal, name, symbol, and the blockchain timestamp. Okay. All right. And yeah, we got the same output, so we are happy. Okay. This data is also available for you through GraphQL, right? So GraphQL, if I maybe go back here and show back my my database list, like here. So here in my database Ethereum, I also have the Connect tab. Okay, and in the Connect tab is all the way available to you to connect to this database. So you can there generate a token. If it was not done before, you can access to file needed for the drivers. You can access to the CLI to interact with your database. And here you also have these multiple API. Here I will pick GraphQL API. Okay, and in the GraphQL API, you can access the GraphQL Playground. And the GraphQL Playground is initialized already with the credential in the header, already with the request, already with two tabs. One tab is for anything with schema, and the second tab is anything with data. And I'm already authenticated, so I can just run that. And here I get the list of key spaces in my database. Okay, I can also so maybe better way to format here is say it's a query. So in GraphQL, two things: query for read-only queries and mutation to edit the content of your blockchain. So it's the name of my query here. I want to retrieve the key space, and here I want to get the name. You will have the same request very quickly. Okay. And to open this request, so now it's more the hands-on part for you as well. So I will ask you to go here to the GraphQL free playground. Oh, it's already populated for me, but I will read it with you. So here, look at the URL. I'm in the GraphQL demo mid like you. Okay. And first things to do, we are asked to change the URL. what is the endpoint of GraphQL? Okay, this is the GraphQL endpoint we want to use. Okay, what is a request? Well, we want to use, we need to change as well the token. So here I'm copy the token in the header. So by default, the header is hidden like that. So you click on header, you paste your token like that. And because now you have your request, you have the authentication, you have the proper URL, you should be able, like me, to execute the data and get access to the data, including the Ethereum. Okay, so it's mine copy of the blockchain, but you can use it. And later on, when you will have your own database ready, you can either use the embedded playground in Astra, or you can just change the token. Okay, so now we are ready to keep working with this GraphQL playground. So first thing with GraphQL, very interested, is you have access here to the schema. And actually, I should maybe refresh. Oh, here it is. You have access to the schema and see what are the different functions available. So here we are on the schema endpoint, and you will interact with the schema. So create table, drop table, update table, and the queries are list key spaces. So what are the list of key spaces? Here, key spaces, this is the name of the function I'm using. What if I want to use this one, okay, key spaces, and list what's available in the key space? So here I want to list the tables, and for each table I would like to list the column. See, it's really just read the schema and you should be able to go with it. Also in the playground you do have access to you have the auto completion. So if I say get one key space here, I will say now I would like to access the key space. I will locate a key space from its name. Here Ethereum. Okay, and then you will decide what are the outputs you want to have. Okay, so here if I want just the name, okay, well, it will look very similar of what we had, right? We get a key space with only the name, but here maybe we want more things. So again, you have completion. So what if on top of the name I want to have access to the different columns? Okay, here it is. And for each column I would like to maybe see the name. Okay, so name of the key space. Now I want the tables. This is what we saw in the schema. First table and then column. Okay, so and see, if I provide a wrong, I get this error message that is helping me. So I want to have access to the table. Okay. All right, so let's go one by one. Okay. All right, and here I want to name of the table. Okay. So here I got not only the key space main, but also the name of the table. And now I can go up to get the list of column, and this is where I failed before. So now for each table, if I want to have access to the column name, this is what I do. See, so it's a tree. So in trace by data, this is all the column, and I can keep doing and say, okay, so what are the type of columns? So and say, let's say I want also the name, but this time is in info. I want also the basic type, and it's okay, no error. And here you go. So now for each column, you also have the date, the type and the info. Okay, info, name. Yeah, I think I'm good. So no description on those fields for that. Okay, so far so good. All right, keep moving. It was query to get the schema. And remember, this copy of blockchain is read-only, so we are only doing queries and not mutation. So second thing we can do, and this time I will do it with you, maybe better. I will create a new tab because here the URL is really for schema. And now I want to get the URL as well to interact with the data. Okay, so this time the URL to copy is this one. And as you can see, it will end up with the key space name Ethereum. I need to provide the header if it's not already populated. So for me here, it's still okay. And now I will execute a mutation to say, this time I will copy paste. So I will use an existing address. How to know about an existing? Well, you can still go here. This one is probably existing, right? I should probably or could probably copy this one, just you know, if we want. It's maybe the same, right? C14 blah blah blah, and end up with 92. Maybe it's already him. Yeah, it seems to be already him. So, and here, if you look at the schema, you have queries on all the blockchain table. And here I will list the values, address, blockchain, title, symbol for the token in the token tables with the address. Okay, one thing to realize here is address colon is in red. This is our partition key. So that means this is what we need to provide in the where clause to get some result. And here we go, right? We get the same values as what we have in SQL, which is, of course, expected, right? Okay, with that, we are done with the interactive with GraphQL. Pretty cool. All right, everybody. After seeing what a blockchain and Web3 could be, what is Astra database and what you can do with that, the GraphQL API, discuss about Astra Block, let's do the demo. Let's build a real app on top of Astra Block. So the app is called Ethereum Block Explorer. You saw the demo before, but I will not be the one doing the demo. Now I'm joined by Alex Leventer. So Alex, could you please first introduce yourself?
Yeah, absolutely. Well, first, thanks for having me, and thanks everyone for joining. I think we have a super exciting demo app for you to play around with. So a little bit about me. I'm a JavaScript TypeScript developer. I've actually built a large portion of the Astra user interface that you're playing with right now, and I've been a TypeScript developer for several years now, kind of before it became cool. Other than that, I do a bunch of open source Web3. I work with a bunch of open source Web3 projects in my free time. And previously at DataStax, I've had a bunch of different roles. I worked on product-led growth, and I've also worked on digital marketing. So what's super fun is, not so long ago, I was helping Cedric promote these webinars, and now we're doing one together.
Very nice. Okay, so before Alex doing the demo, let me remind you the architecture. So you do have public blockchain, Bitcoin, Ethereum. So today we work with Ethereum, the Astra Block component that listen all these events happening on the blockchain, get the replication. When you create a database in your Astra organization, you also get a copy. And we will access those copies using Stargate GraphQL API, as you tried before. And what we want to show you now is the user interface, the JavaScript application. So now it's time to jump into the code. I will let Alex share his screen and I will be quiet for now. So now, Alex, you are sharing. Let's go into demo mode.
Yeah, absolutely. So I have gone ahead and cloned just the Block Explorer repo. If you haven't done so already, I'd recommend you pull down this repo from GitHub. And I've just pulled up the package.json. So this is just a Node React Next.js app. Just a little bit of kind of reminder for all Node apps, they have just this basic package.json where you can see all of the dependencies along with kind of the basic commands to build and run the app. So I'll just walk through kind of the basic commands here for you to play around with the app. So yarn dev, you'll want to run this command if you're actively adding features. This just does some hot reloading. Yarn build is just the production build, right? So running this command will generate the production build for Vercel, which we'll show you how to do in a bit. Start is just the production start command, which we'll also show you in a bit. And probably one of the most interesting lines here is this generate line. So what this is doing is we're using GraphQL code gen to read from the Stargate GraphQL endpoint that Cedric mentioned and generate all the types. So what I think is especially interesting about this app is we're using entirely the GraphQL APIs from Stargate. So now that I've kind of walked you through some of the basic commands, I'll walk you through some of the structure of the project. So kind of the big pieces are, you'll see this components directory. So here is kind of all your React components. So when you kind of play with the app, you'll see we have some basic pages, right? We have a page for blocks. We have a page for the block details. We have a page for the transactions details. Again, all of this information is pulled, all this data is pulled with GraphQL through the Stargate APIs. So very, very interesting. If you scroll down a bit to the pages directory, you'll see within it, there's a API directory. This is just the standard structure for Next.js backends. So you'll see, I'm just going to pull the get block sitemap. You'll see all the data is pulled server side. If you scroll down a bit, you can see we're using kind of the code generated with GraphQL type gen, and all of this is talking directly to Stargate. Cedric, anything I should add? Any kind of questions so far?
No, to me it's pretty clear, and I find cool that you can generate the full client for your GraphQL endpoint. It's just you don't have to build the HTTP request yourself, and it makes you gain a lot of time. Also, Next.js is doing a lot of stuff for you on the backend side, so you can focus on just building your components. Pretty cool.
Yeah, I think probably a underutilized feature of our Stargate APIs, right, is you super quickly can create your Cassandra tables in Astra and use something like GraphQL type gen to basically generate everything you need to interact with like your backend in seconds. So really would recommend checking out GraphQL type gen if you haven't already. Cool. So now that I've done kind of a basic overview of how the app is laid out, right, the backend, the components, I'll walk through how to deploy this thing. So if you go to the README, you'll notice there's a Vercel link on the very bottom. This is basically the Vercel one-click deploys. So I'm just going to go ahead and click this link, and I'll change my share to my browser. You'll notice there's the same link at the bottom of the DataStax devs README. I'm just going to scroll to the very bottom. And now this will make a little bit more sense. I'll actually click this link. And doing so is going to take me to Vercel. So if you haven't created a Vercel account already, you'll need to create one. It takes a couple seconds. And you're just going to be asked for some basic information. The first is you're going to be asked to name your repository. You can go ahead and name this essentially anything you want. I'll just name this demo 123. And once you've done that, you're going to be asked for 2 environment variables. So for the workshop today, we've gone ahead and provided you these 2 values. After the workshop, you'll be able to create these for your own database. So I'm just going to go ahead and I'm going to plug in my sample token. And this is just my Astra token that you'll be able to generate on your own later. And I'm also going to plug in my GraphQL endpoint. So probably mentioned it a little bit too much now, but this is automatically generated using Stargate. So once I've done this, really it's as simple as clicking this deploy button. And now what's happening is we're running a couple of the commands from the package.json that we discussed earlier. First, we run the yarn build, which will build the entire project. And then once that's complete, we'll run yarn start. And while this is taking a couple minutes, I'll just go ahead and show you kind of a working example. So once you've deployed, you'll see something like this. So here is a real-time working Ethereum Explorer. All this data is real. It's pulled directly from Astra Block. I can see the second a block is mined, we immediately pull that data into Astra Block, and then this app reads from it. I can see kind of the transactions component that we talked about earlier. But all of this is real blockchain data pulled directly from Astra Block. And then this is just the Next.js app that we discussed that you've deployed to Vercel. Well, that is pretty much it. Cedric, is there anything else we should cover on the sample?
So first, thank you very much for the demo. And I was wondering, so with Astra, as I explained, you can start for free, and you can even do 80 million queries a month, so any side project, student project, small prod will run for free, just on the data side of thing. And on top of it, you show how to, for free as well, deploy the app on Vercel. So you have your whole free apps running in prod. You just have to get the revenue now. But if you clone Astra Block, it's quite a lot of data. So be careful. It could generate a lot of volume, and maybe you can go above that limit. But for small data set, you're very good to go.
Absolutely.
Okay, all right. So now let me share my screen back. Here we go. I'm now sharing my screen, and I will move you to the wrap up. But Alex, thank you again to join us during this workshop. And if you have any question here, please ask in the YouTube chat, or if you are now watching a recording, simply send us a message on our Discord room. Again, Alex, thank you very much for coming. Okay, and we are back with only me. Nice demo from Alex. Okay, we are almost already at the end. So what's next? So we show you Astra Block. It's available right now for you to try. Request access. Wait a couple of days. You will have access to it. Be careful with the pricing if you copy the full database. Get ready. So for now, it's only the blockchain, but more sources are coming. So Solana is almost there, a graph and subgraph support. And also we will shape the data in an easier way to consume. To learn more, a lot of links that I will provide you in the description below. I will also, you also have access to the slide as a PDF, so you can go there and see all the small details, Web 2 versus Web 3, what is Ethereum, what is blockchain technology, if I did not do a great job explaining. And next week, March 14th, we will have a big event, Cassandra Forward, so more than 2,000 registration already, with people from the Cassandra project. They will explain you what is the future of Cassandra, what's coming for 5.0 later this year, new exciting features like ACID transaction, now part of Cassandra. So please take the time to go there and subscribe for the Cassandra Forward. To stay in touch, always Discord. We are there 24/7 answering your question on the different workshop, and not only on any Cassandra, Pulsar, and Astra question. If you want to learn more about Cassandra, we have the Academy, academy.datastacks.com. If you want to know what the workshop's coming, go to datastacks.com/workshops. And if you enjoy the session, please subscribe to the YouTube channel. This is why make us coming back every weeks or every 2 weeks now and provide you this diversity of content. You could have a look in this video. We have more than 30 content for you across Python, JavaScript, Java, NoSQL, Graph. So, go there and have fun with us learning. And with that, it's a wrap. Thank you very much for attending. I will probably stay a bit longer in the comments for you to answer any question. But with that, thank you very much, and hope to see you in 2 weeks then. Have a great day. Bye.
Do the demons of NoSQL got you down?
You must go to San Jose and seek out the Cassandra Summit.
Been wanting to go to the Cassandra Summit, but now it's been delayed? No worries. Just fire up your own computer and register for Cassandra Forward. That's right. Tuesday, March 14th, we're hosting Cassandra Forward, which is a free and virtual event. Just go to www.cassandrasummit.org/Cassandra-forward. Register and level up. And get back out in that NoSQL quest for glory. Data stack. Data stack.